Let's navigate to Property page, Limits tab, and activate Limit Calculation mode. In this mode, all the measurements we do are stored in the reference unit list here and are the base for calculating any kind of shifted or statistical limits according to the limit settings on the right side. So let's start with our first reference unit. I have a batch of units here which are not defined as references explicitly. So we can just measure a few and see how the variance is and if there are any good or bad units. So we can finally define the limits based on the good ones. In limit mode, it is recommended to already use the barcodes so we can track the references clearly by their serial number. Alright, so we can find our first measurement here. Let's enlarge the page so we can see the full serial number. And with this checkbox, we can activate or deactivate this reference. After having measured 10 reference units, we can stop and take a look at our recorded data here. So all the 10 measurements are listed in the DUT list here, so we can find the number of the reference units as well as the scanned serial number according to the serial number label. So let's move the property page here a bit so we can have a free view on all the results windows. So if we click on one of these listed entries here, the corresponding data set is highlighted in our curve bulk. So we can activate and deactivate individual units and check how the variance changes here in our result windows. As you can see already, we have some outliers in our data set. We do have an automated reference unit check. As soon as we start calculating the limits, all the reference units are checked against those limits. But of course, we can remove obvious outliers already at this stage here. Let's find out which serial number is related to this really bad rub and buzz response here. This is definitely not a good reference for a rub and buzz limit, so let's just remove number 10. This looks much more consistent now. And we also have two outliers here in the frequency response. It's the number 1 and number 2. We should also remove these ones. The remaining 7 reference units look pretty consistent, so we can give it a try and do a first limit calculation based on the standard settings you can find on the right. To do so, we just need to click the calculate button here. As you can see in all result charts, we now have these dashed lines, which are the resulting limits based on the pre-configured settings. So we can find a set of limit for each results parameter that we have. Like for example, the frequency response has a positive and a negative tolerance. It's symmetric in this case, while the rub and buzz only has a one-sided limit because we're only interested in higher levels compared to the reference units. So we have various different calculation settings, which can also vary depending on the result parameter. So for example, the impedance curve here is shifted by plus minus 10% over the whole frequency range. Maybe we're not interested in that. Because we have our Thiele small parameters, we have the resonance frequency and the RE. So it's rather complex to check the impedance magnitude. Let's just limit the frequency range to 500 Hertz up to 2 kilohertz with a constant shift of 10%. So let's check again. Yeah, only the upper part here is now tested against limits. So for the frequency response, we might also alter the limit settings. We have a shift in dB here. Let's open the shift mask. So the limit is defined between 20 Hertz and 2 kilohertz. So maybe the passband starts here only at 50 hertz. So let's change the start frequency. Maybe we also want to add a second set of limits for so-called grading. So we can make a difference between very consistent or very good units that are close to the reference average pool and the maybe lesser ones which are still in the tolerance. We can add another limit here. Maybe 1.5 minus 1.5 dB. Between 50 Hertz and 1K. And above that, we can increase the tolerance to 3 dB. That's it. Let's calculate and check. As you can see now, we have an additional limit set here. As long as the response is within the inner tolerance, this result will be grade 1. By the way, you can see this limit already here in the normalized view of the frequency response. It looks a bit funny here because the response and the limit are related to the golden reference unit. Since the limits are based on the complete statistical average, there's a slight deviation here. By the way, speaking about golden units, when pressing the calculate button, the golden units are identified automatically based on the frequency response. The frequency responses that meet best the reference average are listed here in this table. Reference DUT number 5 is the one that represents the whole batch. So this is going to be our golden unit, which is also used for limit calibration in production testing. So we should put at least one of those units here on the shelf for limit readjustment. What we can also see here, we have one failed unit in the impedance task. So let's check out what's the reason. So we have a fail here in QTS. So this one seems to be an outlier. We have a limit here. It's based on a 15% shift, and the unit 1394 violates the upper limit, as you can see here. So we should also deactivate this unit and check again. So finally, all the reference units are passing the limits at this point. Before finishing with the limit setup, let us also check out the Rappenbus limit settings. As you can see, the limit follows our reference pool responses quite closely, but at very low levels, we don't need to be too strict. So it might make sense to have a certain limit floor. We can add this here. So we have a 6 dB shift based on the worst case scenario of a reference pool. And let's add a -60 dB floor related to the average level of the frequency response. So what happens now? Yeah, you can see here that we are much less sensitive for tiny peaks in the Rappenbus, maybe at 40 or 50 dB SPL, which is pretty low. But in order to still identify units that are not as good as the references, we can also add a grade limit here. So maybe a 3 dB shift and a -70 dB floor. Let's check again. Now you can see our grade limit here, which is a bit stricter than our pass-fail limit. Okay, let's wrap up the limit calculation at this stage. We just have to leave the limit calculation mode, and all the measurements we do now will be checked against those limits. Let's give it a try. As you can see, the unit that we tested right now fulfills all the limits, so we get an overall pass verdict, and all the individual verdicts are pass here. We don't get an overall grade because in the Robin bus, the grade 1 was not achieved due to a tiny distortion peak. Here it's still within the pass range, but it is not sufficient to fulfill also grade 1. You can also check out the normalized frequency response view, and you can see that this unit is pretty close to the golden unit response. The maximum deviation in the passband is around 1 dB or less in most cases. Since all looks fine now, we can move over to the operator mode and do some real production testing. First of all, we want to reset the statistics, so we start with 0, and we can also activate our user administration in order to prevent the operator from changing any of those settings here. I have already added 2 accounts here, one for the operator, one for the engineer, and we have some pretty simple passwords here just for demonstration purpose. Okay, let's log out. If we're satisfied with our test at this stage, we can just back up the settings and make sure that they are not changed and save this as a template. So actually, we can take the same name. The folder path is determined automatically, and let's hit OK to create the template. In case we have multiple production lines and want to share this test program with all those lines because we have identical products tested on all lines, we can create a master test based on this test. If we do this, the test is stored on a central server location that was defined in advance, and all the production lines will update the test settings from the server each time you open the test sequence. You can identify all tests that are linked to a master test by this double arrow symbol here.